Alright guys, for this video we're just going to do a quick introduction of, this is going to be the last method that we're going to use to solve a linear system, and it's called the elimination, or we could say linear combinations method. First thing you can do, you can just stop the video and just take down the definitions right now that's written in red for elimination and the whole goal. So go ahead, stop that and take the definitions down. Okay, hopefully you took down those definitions. I'm just going to kind of highlight, kind of go over what elimination is and what the goal is, and then do the first three. Okay, so if we look, elimination, we're going to add or subtract the equations, and the whole goal is we want to get rid of one variable. We want to eliminate one variable. So if we can get rid of one variable, I can solve for whatever variable I have left. Now here's the main thing, the whole goal. I want to get the coefficients of x or y to be opposites of each other. Because if we can add opposites, they're going to cancel out. And I'll just give you a quick example right here. If I have two equations, and let's say one of the equations I have 3x, if I can get the other equation to be the opposite, negative 3x, if I add those together, they go away. 0x is just 0. And remember, coefficients is just this number, the number before the x or the number before the y. So we want them to be opposites. Okay, so when we look at these first three, the main thing we have to do first is we have to have all the x's and the y's lined up. And that's actually the case when I zoom in. If you actually look at 1 and 2, if I look at 1 and 2, they're all lined up. So you can see, look, I have these x's are lined up, the y's are lined up, the equal signs are lined up, and the constants are lined up. Same thing for this, x's, y's, equals, and the numbers, they're lined up. 3, they're not lined up, so we're going to have to rearrange that a little bit. All right, so if I do number 1, the good thing about number 1 is I notice I have opposites for y. This is negative 3y, and that's positive 3y. So according to that definition, if I have opposites, I'm going to add those two equations together, and I'm going to add the like terms. I already have the like terms lined up, so I'm going to put a little plus here. And this is going to be, that means equals after we add. So if I add this x plus this 4x, I get 5x. When I add the 3y and the negative 3y, they eliminate, they go away. Right? I put the equals. When I add the 4 and the 6, that's 10. This is why I like this method so much. If you look at that, after you eliminate it, you have a one-step equation. It's a lot less work than substitution. So here you would divide by 5. And 10 divided by 5 is 2. Now, to get the y value, we're actually going to go back to the substitution method. I could plug this x equals 2. I could plug in either this x or this x. I'm going to plug in this one just because the numbers are smaller. So I'm going to substitute 2 in for this x. So when I do that, I'm going to have 2 plus 3y equals 6. So we're just working with that first equation. Subtract 2 from both sides, and we're going to get 3y equals 4. And this one's going to give us a fraction. So we divide by 3, and we're going to get y to equal 4/3. All right? Let's go to number 2. Okay, I forgot to put, remember, the answer. X is first, it's 2, and then 4/3. Okay, if I move over to 2, let's kind of zoom in here so we have a little bit more space. The good thing is everything is lined up. The x's are lined up, the y's are lined up, the equal signs lined up, and the constants, negative 4, negative 1, they're lined up. Then I ask myself, do I have opposites either for x or for y? Well, if you see, I don't for the y's. These are not opposites, but these are. This is positive 1x, this is negative 1x. So that tells me I can add these equations together. So let's do that. So when I add the x's, these eliminate. When I add the y's, pay attention to the negative before it. Negative 2y plus negative 3y is negative 5y. Right, I line up the equal sign, and then negative 4 plus this negative 1 is negative 5. So just like that, I have a one-step equation. Divide both sides by negative 5, and you're going to get the y to equal 1. And then again, to get the other variable, we go back to substitution. Now, since this is y, I could plug 1 in for this y or for that y. I'm going to do this one right here. You could do either one. It's still going to give us the same x value. So I'm going to plug this y equals 1 into that y for that first equation. So I'm going to have x minus 2 times y, which we figured out is 1, and it equals this right here of that negative 4. So then when I multiply this, the 2 times 1 is 2. So I have x minus 2 equals negative 4. And then after we add 2, we're going to get the answer for x. Negative 4 plus 2, that is negative 2. So I have the x, I have the y. If we were to graph those two lines, remember put the answer in order as an ordered pair, it's negative 2, 1. All right, so those were probably the two easiest problems to do with elimination. We'll probably start off in class doing this one, number 3. And the main thing with this, with number 3, is the like terms are not lined up. So that'll probably be the first thing we do in class. All right, so that gives you a good intro of how to use this elimination method.